morning, sir. My name is Dinesh Kumar. I am from second year mechanical. Today, my topic is a classification of welding processes, types of welding joints, and their characteristics. Introduction to welding processes. Welding is a process of joining materials, typically metals or thermoplastics, through the applications of heat, pressure, or both. The choice of welding process depends on the factors such as materials type, joint design, and desired mechanical properties. Understanding welding processes is essential for ensuring the quality and performance of welded structures. Classification of welding processes. Welding processes can be broadly classified into fusion and solid state welding techniques. Fusion welding involves melting the base materials and added a filler material, while solid state welding occurs below the melting point of the materials. Each classification encompasses various techniques tailored for specific applications and materials characteristics. These are the classification of welding process. Welding can be classified into solid state welding and fusion welding. In fusion welding, this is also classified into three types: autogeneous welding, homogeneous welding, heterogeneous welding. In the autogeneous welding, there is no filler material. In the homogeneous material, filler materials of the composition same with the base material. Heterogeneous welding, in filler materials of composition different from the base materials. Fusion welding processes. Fusion welding processes includes shielded metal arc welding, that's called SMAW, and gas metal arc welding, this is GMAW, and gas tungsten arc welding, this is GTAW. These processes utilize heat generated from an electric arc or gas flame to melt the base materials and create a strong bond. Fusion welding is widely used in industries such as construction, automotive, and manufacturing for its versatility and effectiveness. How does metal arc welding works and what are its types? Solid state welding process. Solid state welding encompasses processes like diffusion welding, friction welding, and ultrasonic welding. These techniques rely on mechanical pressure and heat generated through friction or ultrasonic vibrations to join materials without melting. Solid state welding is advantageous for joining dissimilar metals and preserving the mechanical properties of the materials. Types of welded joints. Welded joints can be classified into main four types: butt joint, corner joint, lap joint, and T-joints. Each type of the joint has its own design and load bearing characteristics, making them suitable for different applications. Proper selection of joint type is crucial for achieving the desired strength and integrity of the welded assembly. These are the pictures of different welded joints and its types. The first one is butt joint, and second edge and lap joint, T-joint and corner joint. The first one, butt joint. Butt joints are formed when two pieces of material are aligned edge due to edge and welded together. This joint type is often used in applications requiring high strength and is commonly seen in piping and structural components. Butt joints can be welded using various processes including TIG, MIG and stick weldings. And the second one is corners joint. Corner joints are created when two pieces of materials are joined at a right angle, forming a corner. This joint type is frequently used in frames and enclosures, providing good strength in applications with limited space. Corner joints can be welded from the outside or inside depending on the accessibility and design requirements. These are the pictures of the types of corner joints. The first one is flush corner joint, and second one half open corner joint, and third one full open corner joints. And next one is lap joint. Lap joints are formed when two pieces of materials overlap each other, creating a joint that is often easier to weld. This joint type is commonly used in sheet metal applications and is effective for joining thin materials. Lap joints can be welded using various processes including spot welding or continuous welding, depending on the applications. And these are the pictures of the lap joint. First one is half lap and mid-thread half lap, cross lap and dovetail cross lap. And next one is T-joints. T-joints are created when piece of material is joined perpendicular to the surface to the another, resembling the letter T. This joint type is commonly used in structural applications, providing good strength and sustainable stability. T-joints can be welded using various methods such as MIG welding to ensure proper penetration and fusion. Edge joint. An edge joint connects two pieces of material along their edges. This type of joint is commonly used for thin materials and in applications where space is limited. Edge joints can be more challenging to weld effectively due to limited access. Plug joint. A plug joint involves making a hole in one piece of material and inserting another piece into it. This joint is often used in applications requiring tight connections and is strong under tensile loads. It allows for effective welding at the interface of the two materials, enhancing strength. Slot joint. A slot joint is similar to the plug joint but involves a slot cut into the base materials. It provides a larger area of welding which increases joint strength. Slot joints can accommodate thermal expansion better than the other types of joints. Welding positions. The position of the weld can be significantly affects the joint's strength and quality. Common welding positions include the flat, horizontal, vertical and overhead. Understanding the welding position is crucial for achieving optimal results. Conclusion. Understanding the classification of welding processes and the types of welded joints is essential for effective fabrication. The choice of welding methods and joint types significantly affects the performance and durability of the final product. Proper training and knowledge in welding techniques leads to improved quality and safety, manufacturing and construction. Thank you.